Recording. Okay, sorry. Uh, yeah. Oh yeah, by the way, just a reminder, I'm not going to be here this coming Tuesday. I have a family thing came up. I apologize. Um, but I'll make it up with extra preparation for the midterm and final. Okay, so um, uh, yeah, so I'll show you a really simple example over here. So let's go back to our previous project. Okay. So let's say, for example, um, I have a um, let's do I have a math class here? Here, math. Okay, let's have this math class over here and have a method called sum. And what it does is it it takes a okay, so here I'm declaring the parameter of it, right? So I'll actually I'll make it public. And I want to pass it a list of, let's say, integers. Uh, I think I have to do integer like that. And then list, and then I have to tell it to import that class, and then I could go for oh, and I could go through. What went wrong? Nothing. Okay. So then, for example, I could say int sum equals to 0. And then I could say I could just do my loop. I could say for each int this is in Java, you could do this in list. I want to do sum plus equals to I. Something like that, and then I return sum, right? Actually, there might even be other ways to do it, but okay, okay. So what's notable about this method is that I specified a list of integers, right? Now let's say I want to pass something, okay, let's say for example, now let's look at list for a second. If you look at list, it's actually inherits from collection, right? And collection inherits from iterable, right? And iterable, that's it. Okay. So inherits oh, that's interesting. Inherits. Okay. So if I would, okay. So now let's do two methods. Oops, sorry about that. So let's say I have two methods, and this is called, um, I think it's iterable, iterable, and again, integer. And we'll call this one sum2. Okay, so one of them, and you see that both of these are going to compile, except that what's the difference between these two? This requires a list, but this could take anything that's iterable, right? So for example, let's say in main, I have an iterable. I have a um, iterable integer list equals to new and iterable. Now, uh, Let's do array list or something. Okay. So the point though is if I call, if I do math equals to new math, right? So let's say I try passing, I'm sorry, uh, the other way around. If I have not iterable, I have list. Okay, so over here, I have a list, right? So if I want to call math dot sum two, let me think for a second. Uh, it, wait a second, it will, oh, it will not work, right? So I can't pass it the list. I could, wait a second, I could pass it. Wait a second, because list, oh, and here it's, wait a second, wait a second, if, oh no, it's the other way around. Yeah, so, sorry, if it's iterable, and then I want to call sum one, right? Or it's called sum. So now it won't work, right? Why? Because the sum method says I need a more specific class called a list, right? Remember, iterable is a more basic, general, right? Iterate means to go through something, right? Something you go through. So, but this is a list and this has more properties than iterable, right? So over here in main, my code, my sum method won't work anymore, right? Because it requires something that's a list, right? Something that's defined as a list, right? So, but on the other hand, my other class, sum two, right? This will take anything. It'll take either iterable or a list, right? So I could declare it as a list or a iterable, and sum two will not have to change. Isn't that cool? So the more general you make something, then the less um, the less chance you're going to have to modify it, right? Because all I'm doing here is going through I'm iterating. I'm just going through a bunch of numbers, right? So I don't need a list because a list does more things. I don't know. I don't know offhand what a list does. We could probably look it up to see what it does. Maybe it keeps the order of the list, and iterable just says that it's something that you could go through. I assume that list, if we look at it, it it has it has a um, an order to it, and iterable doesn't. Okay, whatever it is, it has certain methods that the other ones don't have. Okay, so okay, but the point is that if all my method is doing is something really basic, then I should make it as general as possible, and then I could pass it more different types. Okay, so this is the dependency inversion principle, right? So according to I should always make my um, parameter type to be the most general as possible. Okay, that makes sense. So we want to be as general as possible, just like with the cook, right? You don't want to be too, because every time we add more requirements for the cook, we get less people who could apply, right? And if all I need is, something basic, so I should just advertise somebody who knows how to make eggs, right? Fried eggs. I don't know if you like fried eggs, but I happen. What? You're what? Scramble, yeah, oh, I meant scramble, yeah. Oh, you mean as opposed to like with yeah, the yolk? Yeah, I just like, yeah, yeah, I like eggs. Um, so it's like one of the few things I know how to make. Okay. Okay, so that's really depends on the inversion principle, right? Without all the, and it's very logical, right? The more general you are, the less, more things are going to work with it. If we only had this method, then we wouldn't be able to, um, sorry, if we only had, um, right, this method requires a list, it would not take a iterable, right? Right, because a iterable is more general. This says I need a specific type, even though in reality it doesn't, right? Right, remember that? Right, if we were doing this one, it won't take the iterable, right? Because the iterable is more basic than some takes, right? It only take a more specific type, which is a list, right? That's the only one that will work with some. Okay, so instead we could do this, and it'll take either iterable or it'll take anything, right? Pretty much. Okay, so that is the that is the dependency inversion principle. Okay, so okay, next let's do another idea called Yagni. Okay, now let's say I make this really simple. It's going to be um, let's say I have, for example, I have class A, and let's say I have class B, and let's say I have class C, and then let's say in B, uh, I refer to whatever, somehow I refer to C, and then in A, I refer to B, right? So this is my code, right? So what's wrong with this code, right? It compiles, there's no bugs in it, right? I mean, I did this really quick, but theoretically, what's wrong with this code, right? I have A, B, and C. It works. It compiles. It should compile, I hope. Well, I'm not in main. If I go to main and I run it, it'll run. So, but there's something wrong with A, B, and C. Could you guess what's wrong with A, B, and C?
It just doesn't do anything.
Well, forget about that. Let's pretend it did something. Let's say, I don't know, it designed a submarine. I don't know, right? But I just did it quickly just to show you that, no, the problem is I'm not using it yet. And let's say, for example, I have I have my math class inside here, right? And let's say I'm doing math. Let's say I have a method called I don't know, let's say public, public void, uh, do something. And let's say it calls math. Sorry, I should make this at least make sense. New math, and I could do math dot sum of something. I don't know. I'll pass it no. Whatever it does. Okay. But the point is that I have this code over here, right? But no one's calling it, right? Is A being called by anybody? No, it's just sticking here. It's calling other methods, but it's not being used, right? It's just hanging out here, right? So what's wrong with that? Well, two things. Number one, if you look at this code, your project, you'll say, oh, I wonder what A does. I wonder what B does. And I wonder what C does. And then, but you're spending time looking at it, but you're not using it, right? So number one, when you keep stuff that's not being used in your project, what's happening? You have to um, you're going to waste your time understanding it, right? Right? And it's not being used, right? You could spend, I know at work sometimes, like you might go to math, like it happens to me all the time at work. Like I'll look, it says four usages, and I'll look at all the places it's being used, right? So it's being used in A and in main, right? So so I'll look over here and I'll see how it's used. Let's say I want to change this math, right? So I'll look at where it's being used, and then um, you know, I'll, I'll be careful if I change, let's say, sum, not to break something, how it's right, because I want to see how it's being used, right? But over here, it's not being used, right? It's here, but it's not doing anything. It's never being called, right? So I could spend my time looking at how it's going to be used over here, and it's passing a null. What should that do? And it's not even being used altogether, right? So the best thing to do is just delete it, okay? Right? Because in the second, so one reason is because it's confusing to somebody looking at this project. They say, "Oh, I better understand what A, B, and C are doing," right? So, but they're not being used. So if it's not being used, just delete it. Don't confuse other people about it, right? That's number one. Number two is is that being that this is part of the project, if I would for some reason, let's say I would change sum over here. Let's say, I don't know, I pass in another something, I don't know, a string, let's say. I don't know what it will do, but let's say I change the signature. Uh, so over here, I would have to fix it, right? Right, in order for it to work, right? Right, but over here, what am I doing? I'm fixing up code that's not being used, right? So I'm maintaining something, right? It's like, for example, let's say you have an old lawnmower in your garage that you haven't used in 10 years. And every spring you take it out and you clean it out and you clean out the motor. I don't know what you do. You do some type of maintenance on it and then you put it back in the garage for next year, right? And you have to maintain it because or let's say you have a car you don't drive, you have to like every week, I think, to start the car or the oil uh, turns into sludge, whatever, and the battery dies. So a car has to be, at least a gasoline car has to be turned on every once in a while, right? It's not good for, in general, for machines not to be used for a long time, right? Or let's say a washing machine, if you don't use it for a while, the rubber becomes, it becomes very brittle, I think, right? So in general, even though, so even though you're not, so even though I'm not using something, I still have to maintain it, right? So the idea, so those are the two reasons to go ahead and just delete these three objects, okay? Because it's unused code. Okay, so even though I spent time on it and I thought I was going to use it, but since I'm not going to use it, so get rid of it. Okay, so that's called Yagni. You aren't going to need it anymore, and I have it somewhere here. A Yagni. Okay. Oh, actually, I wrote these two reasons. In other words, it's confusing. Number one, we just said that. And number two, you end up spending time maintaining code, which will probably be never be thrown out, right? Anyhow, so the idea is don't be the equivalent of what's it called when people save things, what are they called, a what? Hoarding, right. Don't be a hoarder, right? Right. No, it's get rid of things, right? Right. What is the rule? If you don't use something for a year, throw it out, right? Right. I just went through my drawer, my one of my I thought I have a lot of I had trouble putting things into I was trying to fold things and put it away in my drawer. And then I said, wait a second, I'm putting these things I haven't worn in like 5 years. Why am I spending time folding it and putting it away, right? I just took the whole pile and threw it out. I didn't even look at what I was throwing out. I said, there's nothing in here that I've used in 5 years. So I just threw it out. So, um, yeah, so that's the idea that there's a cost to keeping things around, right? Now I have a lot more room. Because I threw out the stuff that I didn't need anyhow. I wasn't using. I mean, you might say, well, who knows? Maybe in 5 years you'll be looking around, and in this one might be, that's always the hoarders, you know, that's always the reason why they hoard, because it might be that in 10 years somebody might come by my house and they'll need to wear this jacket because it's raining, and you know, but chances are. It'll be, by then it'll probably be full of dust and you won't be able to use it anyhow. So just throw it out, right? So so that's basically what Yagni means is don't hoard code. Don't keep it around if it's not going to be used. Okay, we did dry, which is don't repeat yourself. Do you remember what's the idea of dry? Do you remember that? Don't repeat yourself? Like, what's the basic idea?
The code section in one place.
Right, the logic to doing one thing should be only in one location. So therefore, when you want to change it, you only have to change it in one location. You don't have to look through the code, say, oh, where did I do this, right? Okay. It's very important, especially when you deal with like programs that deal with languages, right? So, if you're dealing with different languages, then sometimes you have to handle, things differently in different languages. So, like, if you have, like throughout your program, you say, if it's French, do this, if it's Spanish, do that. So then, what happens when you realize you want to change what it does in Spanish, you want to add something, right? So so you would really want that just to be in one location, right? You don't want it all throughout your code. So then you have to search for where you're adjusting your code for different languages, right? You just want to do that one spot, fix that, and then you're good to go. Okay. Uh, Depending version principle, so we just explained that. Then we said we didn't do this one. In this one, it's really it's really for solid. So it's for the I of a solid. And basically it's very pretty simple. Basically it's saying like this. He's saying that let's say I have an interface. So let's say it's called math. Let's say it's called, I'm tired of math. Let's do um, comp writing. Okay, like English writing. So, um, right. So, um, oh, I'm sorry. Right. So we have an interface English writing. So, or let's call this English paper. So, or let's say term paper. That's a better, right? So in order to create a term paper, you're going to have to have let's say you're going to have um, again, I'm just going to put in some stuff, uh, a header method, a, um, a footnote method, and then I'm going to have to do a, um, let's say, um, a email or hand-in method, right? So I just have to change the name of the file. Okay. So let's say, for example, I want to do um, a um, I want to do a final project or a project, we'll call it, or let's say class project. And it has to implement a term paper, right? So now, because I'm implementing it, what do I have to do? I have to create all these methods, right? I have to fill in header, I have to fill in footnote, and I have to fill in hand in, right? But if you look at it, hand in is really not part of the term paper, right? It's really, well, I mean, depends on the teacher, but usually it's really not part of a term paper. It's really something else, right? But the fact that it exists within um, the fact that it exists within this interface forces my project to have to implement this method, right? So basically, the idea is that whatever, an interface says, these are my capabilities, right? And in order to implement an interface, you have to do all of them, right? So I can't just delete this. I can't say, well, I'll do only 2 out of 3. I'll do footnote and header. See, it doesn't like that, right? Because in order to implement an interface, you have to do everything inside the interface, right? So basically the um, interface segregation principle says is be careful what you put into the interface because whoever is going to implement it is being forced to do whatever is in there, right? Right? I don't have a choice to only do 2 out of 3 or 1 out of 3. I have to do everything that's in this interface, right? So the idea is be careful to make an interface only have things that are related to each other. Okay? Now let's think about it basically. Don't put things, don't force the person who's going to implement it to do more things than they really need to do, right? So that's the idea of interface segregation principle. Means don't force a class influence interface to create methods that are unrelated to each other. Okay? So that's interface segregation principle. Okay. Um, okay, and maybe I should fix, uh, maybe I'll just, I'm not sure what I meant over here. Uh, okay, I'm just gonna delete this stuff because I don't know what I meant over here. I mean, I know what I meant, but it's, okay. Okay, so now I think we're done with the salad. Um, get rid of this. Um, okay, so we'll go back just for the midterm review. Okay, but if you have a chance, look over this. Okay, so now I like to do is let's see, we have two choices. Um, you want to do UML? Yeah, let's look at UML. Okay. So what I'd like to look at, we've already done a little bit UML, right? We did already, remember the types of relationships we already did what's called a UML class diagram, right? So, so let's look at what we've done so far. So we've done so far, uh, look at a specific type of, by the way, what does UML stand for? Right. Do you remember the history behind it? What you don't remember?
the-
Uh, when was that? It's really weird because it, when was there were like four different, um, like consultants, like when this whole idea came out, and each one had this separate notation, how to draw things. So they got together and they agreed on one type, and that became known as UML. It's really silly. So, that's why it's called Unified Modeling Language, because they agreed on a particular. Anyhow, there's different types of diagrams you could do with UML, right? So, um, and so what the one we did so far is the class diagram, and the class diagram shows a bunch of relationships, right? So, at least the ones we showed are um, uh, certain relationships. Do you remember what those relationships are?
sound like very,
Say again?
very
Okay, what's that called? Book type relation, it's inheritance, or in UML language, they call it generalization. It means the exact same thing, but they just use a different word. Okay? But you could call it inheritance. Don't worry, we're just generalization. I'm just letting you know because you might see it in a UML diagram, UML generalization. You say, what is that? And it's inheritance. Okay. Um, okay. And then what other relationship could two objects have? Well, we said there's one called association, which means that all we know is that they interact with each other, but we don't know how they interact, right? So it's unknown. There were there it just means and okay, exists some relationship between two objects. Okay. And then we had something called composition, which is a little bit different than the composition. Remember, there's a composition, um, like we prefer composition over inheritance. That's a separate type of idea. Over here, composition means what? What?
They, it's, relevant,
Say again?
self-relevant.
I'm sorry, say again?
It is,
Okay, sorry, I'm not sure. So one object, it means that one object uh, ex is contained inside another object. Basically, it's a member of that class, right? So if you have so basically anytime you have one object has another object inside of it, right? Like we had, over here, um, right? So this, so this is, come on. Okay, so for example, let's say, where's the example? Um, oh yeah, like here. So over here, B is is inside of A. Okay, so A composes B, or B is I think A composes B, whatever. But the relationship is that is that B is inside of A, right? So so composition means that one object is contained inside another object. Okay? Simple enough, right? Now there's one little and actually aggregation is it's basically also one object is contained inside another object, but there's a difference between the two. Um, let's say one object, let's give it a name. Let's say B is contained inside another object, A, right? So let's just copy this over here. Okay, so what is the difference in composition and aggregation? The difference is then in composition, you're going to say, yeah, now it's going to come back to you, you'll see, is that B can only exist within A. B cannot exist by itself. Okay? Well, okay. So that's what composition means. Composition means that, like, let's say, for example, you have a person and they have an eye. Well, the eye can only exist within a person. It can't exist by itself. You can't have a little eye floating around by itself, right? You have to be it has to be inside of a person. Or let's say you have um, something like that, right? Or let's say you have a motor, right? A motor can't exist by itself. It only could exist within a car. Okay. Again, this is not reality. This is how we're defining the way our objects are going to work within our program, right? So we're not saying, well, in real life is how it is. We're saying in our program, this is how it is. Okay. And aggregation is going to say slightly different. It's going to say that um, aggregation says that B can exist without A. B can exist by itself. Okay? So that's the difference between aggregation and composition. And we have one more relationship. And because there aren't too many relationships between objects, right? You could either inherit from another object, you could be associated with an object, you could have the object be inside of you. Like, how many other ways are there for two objects to speak to each other, right? Think about it, right? You look through a program, how could two objects, you know, right? If you look through all the code, right? How do objects, communicate with each other, right? So there aren't too many different ways, right? You could either be inside of it, you could be, right? Oh, actually, look over here. Over here is SQL Server database. Um, well, actually, that is part of it. But let's say, for example, um, let's look over here. Now, look over here. The sum method is being passed this list object, right? The list of numbers, right? And is this list contained inside math? No, right? So what is the relationship between list and math? Or yeah, I should say this list class over here, what is the relationship between this list object and this math object? Right? It's not aggregation, it's not composition, it's not inheritance, right?
It's association.
Well, what? Well, yeah, you could say association of view, right? But we actually have another way of describing this relationship, and the way we describe it is dependency. Okay, so dependency means that it's not contained within it, but the math class won't work unless we have this list object. Okay, so that's the fifth way, I think, right? So the fifth way we have a relationship is a dependency relationship. So, which means that one an object, well, typically a dependency relationship is when an object is passed to another object as a parameter. Okay? So that's a typical dependency relationship, okay? And let's just see how that looks. So if we go over here, we we'll just look at some images. So let's say a class UML class diagram. So let's see if it has image. Okay, so over here we have an example of a class diagram showing what? What do these arrows show? What is it? This arrow? Inheritance, right? The duck, fish, and zebra all inherit from animal, right? Let's look at another one. Uh, um, let's say over here we have a vehicle, we have a car and a bike inherit from vehicle, right? So that's inheritance, right? Okay. What else? Okay, what else are we looking for? Let's look for what else was there? So we did inheritance. Let's do association. Okay, this is um, oh here, I guess. Okay, this shows association, meaning it's not inheritance because a dish doesn't inherit from a from a animal, right? But instead, there's some association between the two. Actually, I don't understand that. Okay, yes, it's telling you there's some relationship, but it's not telling us the exact relationship, right? So that's what the a solid line means, right? Usually, I just leave out the arrows, right? Okay, so that's an association, right? Actually, right? It can't mean inheritance, right? Why? Because because a dish is not a animal, right? Right, but it has, I guess maybe the animal somehow uses the dish, or the animal has their own dish that belongs to it or something. We don't know, right? So that would be an example of association. Um, let's see. Um, okay, over here we have an example of over here we have a diamond, right? And basically, it's a non-solid diamond. So that means aggregation, meaning that a computer is made up inside a computer is a main board, CPU, and memory, right? But since it's a non-solid diamond, it's aggregation, meaning that the CPU could be somewhere else. Right, doesn't have to be within the computer. Maybe it could exist, I don't know, whatever, but it doesn't have to be within the computer. Maybe it could be in a radio, a cell phone, or something like that, right? So that's what this diamond means, right? And then the CPU is made up of these three things, which also don't have to exist within the CPU, which is a little bit hard to understand how that could be, but that's what it's saying. I'm just reading the diagram, okay? So that's what this diagram is saying. Maybe they made a mistake and they really wanted to make this composition, but but that's what it's saying, okay? Got it so far? Right? So if I were to ask you, can CPU exist? Does a CPU have to exist within a computer? No, even though this probably they wanted to say that. Um, let's look for composition. Uh, uh, we need a diamond. Here we are. I'll open this one up over here. And over here, the motor has to exist within the motor and the PLC program have to exist within the case pack or whatever this is. I have no idea what this is. But it's telling us that the motor can't exist anywhere else. And neither can the PLC program, right? Because we have this solid diamond. Okay. And the last one is harder to find an example of. Let's see. Let me Google. Uh, uh, what happened to my Google? Uh, oh, here. Let's look UML class diagram, dependency, uh, arrow. Okay, so let's see if we can find a dependency. So, uh, do they have a good example here? Uh, oh, here. Okay. It's not so easy. Where is it? I thought I opened it. Oh, here it is. Okay, so if you look over here, we're saying that the person is dependent on the movie, meaning that a movie has to have a person acting, I guess, inside of it, right? No, there, or maybe person, uh, a movie is dependent on a person, has seen a movie. Uh, I'm not exactly sure how to read it because usually you see it um, as a parameter. Let me just see. Let's see if I could find it. Tennessee arrow uh, as a parameter. That's usually the example I like. Um, I don't see. Uh, okay, over here they're saying that the coach is dependent on the player. Okay. I usually use a or the car is dependent on the wheel. Okay, so so a dotted line is a dependency relationship. Okay, so the coach needs a player, otherwise it wouldn't be a coach. Can't be a coach if you don't have players, right? Uh, like you can't be a president if you don't have a country. Okay. Okay, so that is our review, right? So this is okay. Um, actually, did I see a summary of a class diagram? I just want to paste it in there. So, uh, class UML. I saw something here. And um, I thought I saw a nice little synopsis. Uh, email class relationship types. Here we are. Okay. Okay, I'll just throw it in here so we'll have it. Okay. This is a summary of what we spoke about, except we didn't do this guy over here, realization and implementation, right? We didn't do that. Okay, we only did five: association, inheritance, dependency, aggregation, composition. Okay? Okay. So next I wanted to, oh, we're getting late. Uh, okay. Uh, hmm. Okay, so I wanted just show you, at least introduce to you, this idea of multiplicity. And basically, the idea of multiplicity is it, let's look at a simple example over here. So, um, so for example, over here, we have a company, right? And it's associated with employee, right? But the question is, if I were, like, I'm wondering, how many companies could an employee work for? Well, the way you read it is you go from employee to company, and I see a one. So that means two things. Number one, that the minimum amount of companies, in order to be an employee, you need a company, and the most companies a employee could work for is one, right? So the minimum and the maximum is one. So employee has to work for a company. So I could ask, so if I would ask you, does an employee have to work for a company? The answer would be what? The answer would be that yes, right? And can an employee work for two companies? No. And how many does a company have to have any employees? Well, when we asked that question, we looked the other direction. So from company to employees, we see that a company has to have at least one employee. Could a company have infinite employees? So there's a star there. That's the maximum. So it has to have at least one employee, but it could have infinite amount of employees. So this is over here. So the one means you have to have exactly one, no more, no less. 0 to 1 means you could have either between either a none or one the most. This means many or infinite, and this is 0 to many, this is 1 to many. Okay? So I'll just take a picture of this and then we'll call it a week. And I guess I'm not going to meet with you until next Thursday. Okay? So, okay, so I'll see you next Thursday. And if you have a chance, look over these things. And then I'm going to try to, um, start chapter 3 on Thursday. I mean, not try, we're going to start. Okay? Okay, so I'll see you. Good night, everyone.